Okay, mask is off since I don't have anybody in the room with me. I promised you guys a quick review. Again, apologize for shutting you out today. But here's the basics of the lab again. Remember, we've got our formula for energy, and you can ignore this for right now. So the idea again in the lab was that we had our calorimeter with the cup inside, and we had water inside here that was cool at room temperature, and then we heated up a weight to maybe 60, 70, 80 degrees Celsius, and then we lowered that weight into here, put the lid on, waited for the water to warm up and for the weight to cool down, and then we took that temperature. All right, and on your sheet you'll see it counts up the temperature every 15 seconds, and then below that it asks for the maximum system temperature. Because what happens is the water warms up for a while from the metal, and then it kind of hits this maximum, and then it starts to cool down again, and that's because energy is starting to escape from the system, and at that point everything's kind of lost. So you want that maximum system temperature. And then here's how you do that calculation. So let's take this out of here for now. So what we can do is, there's some energy that's gained by the water. So the way we calculate that is we take the mass of the water times the specific heat capacity of water, which is 4.184 joules per gram degrees Celsius. All right, and then the temperature change, and our water probably didn't change temperature much. It probably went from around 20 up to maybe 25, 26, something like that, just so you have those comparison numbers, okay? That's the energy that the water is picking up from the metal. So any energy that we calculate here, we're going to plug in to this formula because we want to find the specific heat capacity of the metal. And so the metal is losing energy to the water, so anything gained by the water was lost by the metal. So this energy just goes into here. We divide by the mass of our metal, probably around 56 grams. And our temperature change, which is probably pretty big, probably went from somewhere like 80 or 90 down to about 25 or 26, so maybe like 55, 60 degrees, I think was for your group. This will give you your specific heat capacity, and then you need to know what to compare it to find how close you were. And if I'm not mistaken, your group used stainless steel. So the specific heat capacity of the stainless steel in that kit was 0.460 joules per gram times degrees Celsius. So after you've done all of these calculations to find the specific heat capacity, you compare it to this and you use this error formula. And I've just finally settled in on this one. Just take the experimental value, whatever you got for the specific heat capacity, minus this accepted value. Could be positive, could be negative. Take that number divided by the accepted value times 100 to get your percent error. A couple of my groups were around 14%. All right, so that's how to do that percent error calculation. And at that point, you're done, except for I just want you to talk about some possible sources of error. So let's talk briefly about those. If your specific heat capacity was too low, that's because either the amount of energy gained by the water was calculated too low, or maybe the temperature change was too high. All right. If this thing was too high, maybe extra energy was introduced into the system that we didn't know about, or maybe our temperature change was too low, measured. All right. So there are ways that energy sneaks in. Hot water from the container where we're heating the metal maybe gets in and artificially changes the temperature, right? Maybe energy is leaking out while we're transmitting the weight. Maybe they took too long to transfer it, and a bunch of the energy got lost that we think is in here, but is not actually in here. So if we lost a bunch of energy in transition, that means this number would go down, which means that number would go up, right? So think about where there might be some sources of error. One other one that we discussed, one of my groups in the back, we actually stirred their water with the thermometer, and their temperature went up about 2 degrees Celsius. So, if you increase that temperature about 2 degrees Celsius, this, maybe goes from 5 up to 7. That makes this number bigger than it should be. When you put a bigger number than you should be here, that means this thing gets artificially increased. Okay, so there's several little places where error could come into this lab where we have heat that we think we should, we have heat get in, like we overcalculate it, right? Or where heat leaks out in reality that we can't account for. Anyway, there's your quick video to help you get through those calculations with the end of this.